Read number 5.
Yeah. A balloon manufacturer claims that 95% of his balloons will not burst when blown up. If you have 20 of these balloons to blow up for a birthday party, A, what is the probability that none of them will burst when they blow up? And B, find the probability that exactly 2 balloons burst.
Okay, let's look at this balloon.
Okay.
We have X. What do you think the random variable is? What is it that is happening here?
The number of balloons burst?
Yes. Either a balloon burst or not. So how do you spell balloon? B-L-L-O-O-N. Balloon burst or not? You can put it that way. You can keep it short.
Okay.
Balloon burst or not. Number of balloons will burst or not. But this case, number of balloons that do not burst, because we want to find out, the person says is claiming how many do not burst.
Okay.
So we want to be specific. How many do not burst?
Okay, that's good.
And then now, we know there's two things. Either you burst or the balloon do not burst, which is true because when you organize birthday party, there are some balloons which burst a lot.
Yeah.
So it's a binomial, N and P. You write that. So
Yeah.
what do you think N is?
N would be 20.
Yes, because you've picked 20 balloons.
Yeah. And P
What,
is
what's the probability of bursting?
0.95.
Congratulations, you changed that to decimal 0.95, so it's a binomial.
Yeah.
So part A, what's the probability? And none of them. So you write the binomial formula if you want to show your working. Is NCR P to the R Q to the N minus R. This is showing your working.
Okay.
We want 0. The first one says, what's the probability that none of them burst? So that means R is 0.
Okay.
So probability of X equals to 0. It will be N. What's N equals to?
20.
20C0. Probability is 0.95 to the power 0. And what's the probability of not bursting?
0.05.
0.05 to the power 20 minus 0 to the power 20.
Yeah.
Now, this one, you can easily do it without calculator, not without calculator. Anything to the power 0 is 1.
Yeah.
And then 20C0, you put down your calculator and tell me what you...
Isn't that just 1?
Yes, what did you... Okay. And then what do you go? 0.05 to the power 20.
It would be 9.54 times 10 to the negative 27.
Probability of X equals to 0. 0.05 to the 20. Let's check again. Let me just check here to make sure. What is the probability that none of them burst when blown up? So probability of X equals to 0. So that would mean, well, let me look at it another way.
Okay.
Because looking at this here is different. What's the probability of not bursting?
0.05.
Probability of not bursting. Look at the question again.
0.95.
So 0.95 is the not bursting.
Yeah.
And then what's the probability of bursting?
0.05.
So we wrote them the wrong way around. Does
Okay.
that make sense?
So
If you look at it again, the question says claim 95% not burst. So
yeah.
not burst is a 0.95 and then burst is a 0.05.
Okay, because the question says, yeah.
So you can see the reading in the statistics is the biggest problem. So now it would be 0.95 to the power 20.
Okay, 1 second. 0.36.
Okay. 358 is three significant figure.
Yeah.
Does that make sense? Okay, read the question, please.
Okay. The probability of a switch being faulty is 0.08. A random sample of 10 switches is taken from the production line. Define a suitable distribution to model the number of faulty switches in this sample and justify your choice. Find the probability that the sample contains 4 faulty switches.
Okay, a suitable distribution. Which one will you use?
I'd use binomial.
So X is a binomial distribution, N and P.
Yeah.
It says define. So you might put some words. So
Okay.
X is, there are two possible outcomes.
Yeah.
Faulty and not faulty. And they are independent.
Yeah.
It doesn't affect each other. And then now part B.
Yeah.
So for part A, we haven't finished part A. What is N equals to for part A?
I put 10.
And what is P?
0.08.
That's it. So now part B, find the probability that the sample contains 4 faulty switches.
I got 0.00522.
Okay, let's get the formula first. You copy from the formula book. Probability of X equals to R N C R P to the R Q to the N minus R. Just copying that, that's no problem. From the formula book. Probability of X equals to 4. It will be 10 C4. What's P? 0,
Um, yeah.
0.08 to the power 4. And what's Q?
0.92. I mean, yeah,
0.92. And what will be the power for that?
6.
6. So you get N minus R. So 10 minus 4 is 6. And you put down your calculator, it gives you your answer of
I got 0.00522.
that's 3 significant figures. The first 0 does not count, the second one does not count, so 522. Now, you can write this formula, put the numbers in yellow and work it out. Or you can just put it in the calculator and work it out. If it's 1 mark.
Okay.
So that's number 6 done. That's an exam question for 4 marks. And I think you can do that in 1 minute if you're writing it fast. So congratulations for that one. You read number 7.
Okay. A particular genetic marker is presented in 4% of the population. State any assumptions that are required to model the number of people with this genetic marker in a sample. Sorry, 1 second. In a sample of size n as a binomial distribution. Using this model, find the probability of exactly 6 people having this marker in a sample size 50.
So they want you to, those 4 assumptions for binomial. So if it's a binomial distribution, you have N and P. A fixed
Yeah.
number, N is a fixed number.
Yes.
P is the probability. Either it is genetic marker or not. Either it is present or not.
Mm-hmm.
And they're independent. So you can write those 4 definitions of probability. And then for
Yeah.
part B, one probability of x equals to,
6.
and you come and read the word, it says exactly.
Yeah.
Sometimes they might say probability of at least 6. That means greater than or equals to 6. Sometimes the probability of less than 6. So you go and you look at the number, look at the word next to it. But this one says equals to 6. So you can put the formula 50 C 6 0.04. You change the 4%. 4 divided by 100.04. Right at the top there. To the power 6. And then 1 minus 0.04. 0.96 to the power n minus r. N is 50 minus 6 is 44.
Yeah.
So that's 44. Put down your calculator. What did you get?
I got 0.008.
The three significant figure. And if it's a 1 mark, you can do the same. So that's beautiful. Is 7 marks. A dice is biased. What does bias mean?
Like, it's not fair.
Yes. Landing on 6 is 0.3. Hannah rolls the dice 15 times, so we have enough n. State the assumptions required to models as a binomial. You see, they keep asking this thing, why it's a binomial. So it can take two values. What you want to model is the number of 6.
Yeah.
So your x, which is your random variable, is equals to either you get a 6 or not a 6. Think of it that way.
Yeah.
So you can say probability of getting a 6. Even if you just put probability of getting a 6, that should be good enough. And then there are fixed number of trials. So n is fixed number. You're going to do it how many times?
15.
15 times. And what's the probability for each one?
It would be 0.3.
0.3. And then the other one is to say they are independent. That means the answer does not change. If you do it the first time, it does not change. If you do the second time, the probability stays the same. So it's a tilde sign, it's a binomial, 15 and 0.3. So sometimes in maths, they don't tell you all these words, they just give those numbers. And they want you to find part B says, find the probability that Hannah rolls exactly the word before 4. Probability of x equals to 4.
Yeah.
So that would be 15C4, 0.3 to the power 4, and then 0.7 to the power
11.
11. And you get that by doing 15 minus 4, or n minus r. You can put in your calculator. And what did you get?
I got 0.21. Or like 0.219.
To three significant figure. Yes, always give your answer to three significant figure if they didn't ask.
Okay.
Or to 4, just to get the high accuracy. And then for part C, find the probability that she rolls 2 or fewer. The words are coming in now.
Yeah.
What does 2 or fewer mean?
It means less than or equal to 2.
That means you can get 0, you can get 1, and you can get 2. So less than or equals to 2, that's the choices. You can get 0, or you can get 1, or you can get 2. So 3 things.
Yeah.
Now, you can do each one separately if you use the formula. You will use 15C0 and work it out. You do 15C1 and work it out. You do 15C2 and work it out. And then after you add the answers.
Yeah.
But now with a calculator, your calculator has less than or equals to, does it?
Yes.
So what did you get?
I got 0.127.
0.127. So you use CD,
Yes.
binomial CD, yes. So you can see the calculator will just sum them up for you. But if they show you're working, you can work each one out and then add them up
Okay.
and show the working.
Yeah.
Perfect. Well done, Joanna.